Moving on to a geometric series. So remember, you know the difference between a sequence and a series is what? So make an example of a geometric series is the addition of successive terms of a geometric sequence. Make up an example of a geometric series below. So you should be able to do that. You just take a geometric sequence and put plus signs in between the terms. So what can we do? We could do 3. Start with the 3. Multiply that by 2, get a 6. Multiply that by 2, get a 12. Multiply that by 2, get a 24. Multiply that by 2, get a 48. And that is a geometric series. It's the sum of successive terms in a geometric sequence. What's my common ratio? My common ratio in that case would be 2. What's my first term? G sub 1, it would be 3. We have 1, 2, 3, 4, 5 terms, so n equals 5. And so we would just use that information to plug it in here if I wanted to find the sum. So what is the formula for a geometric series? Well, remember we have G sub 1, which represents the first term of a geometric series. We have the sum of the first n terms. R represents the common ratio. It cannot equal 1. And why can't it equal 1? You can think about that. And then we're going to take it to the nth power, however many terms we have. So why do we say we can put it either way? 1 minus r sub n divided by 1 minus r, or g sub 1 times r to the n minus 1 divided by r minus 1. Well, here we would get a negative answer in the numerator divided by a negative, and negative divided by a negative will make it a positive, which is the same as a positive divided by a positive, which stays a positive. So they're the same thing. Why might we use one over the other? Okay, that's another question. Maybe you'll figure that out as we do these examples. So once again, because we're finding the sum of terms, we probably want to, or we will see the summation notation at some point. So look here, what does this mean? This means we're trying to find the sum of the first 7 terms, right? This indicates how many terms are in that series. You can see it starts with the first term. How do we get the first term? We plug in a 1, so 2 to the 1 minus 1 power. Well, 1 minus 1 is 0, and anything to the 0 power is 1. So my first term is 1. What is my common ratio, right? What is my common ratio? Well, how do you figure that out? You look for the number that's being raised to the power. That's going to be your common ratio. That's what we're multiplying by every single time. So in this case, we're going to multiply by 2. So my common ratio is equal to 2. So G sub 1 is equal to 1. My common ratio is equal to 2. I'm taking it to the 7th power. So I used this formula right here. So now I just have to solve. 2 to the 7th power is what? Some of you might know that quickly based on the 2's. So it's 128 minus 1. 2 minus 1 is 1. So the sum of the first 7 terms of this geometric series is 127. So the sum of the first 7 terms is 127. Now how about the second example? Okay, example number 2. Find the sum of the first 10 terms of the geometric series 3/4 plus 3/2 plus 3 plus 6. So the first 10 terms, so what does 10 represent? That represents the number of terms. We have to find G sub 1, which is 3/4. And then you can see here we have to find the common ratio. So the common ratio is what? Well, how would you find the common ratio? Well, that's easy. You take the second term divided by the first term. Okay, that's a little complicated, fraction divided by fraction, but still possible. We just remember to multiply by its reciprocal, right? And then these cancel, and 2 goes into 4 twice, so the common ratio is 2. Or, to make it easier, if you don't want to deal with fractions, sorry, I'll put it over here, then just take 2 different terms. So take the 4th term divided by the 3rd term. 6 divided by 3, oh, that was easier. So my common ratio is equal to 2. So here we have it. Let's find the sum of the first 10 terms for my geometric series. So my first term is 3/4. And then I'm going to do my common ratio, which is 2 to the nth power, which is 10 minus 1, divided by, once again, a very simple 2 minus 1. So my divisor is only 1 again. Or what I'm dividing by is just 1. So 2 to the 10th power, anybody? 1024. So I have 3/4 times 1024 minus 1, which is just 1023. So 1023 divided by 4 times 3, and I get approximately 767.25, or 767 1/4. So this is the sum of the first 10 terms of this series. And that's it. So does it make sense to end in a 0.25? Maybe you can ask yourself that. Does it make sense to end in 0.25? Well, yeah, it sure does, because here we have 0.75 plus 1.5, which right there equals 2.25, and everything else is going to be a whole number, so yes, certainly we must end in a 0.25 there. Alright, moving on, number 3. Find a formula for S sub n for 9 minus 3 plus 1 minus 1/3 plus ... to n terms. So this one we're just going to find a general formula. So go ahead and push pause, go back up here, look at your formulas, and try to figure out what I need to plug in, what I need to keep as a variable to get my general formula. So n should be your only variable, just so you know. Okay, go ahead and try it. Okay, so does your formula look something like this? It probably, maybe you still have it in this style, but the first thing you have to do to find your formula is find your common ratio. Right, so how do we find our common ratio? You take the second term and divide it by the first term. So second term divided by the first term, -3 divided by 9, which is -1/3. And so there is my common ratio, which I have to put into the formula. My first term is 9, my common ratio to the nth power minus 1, divided by my common ratio minus 1. Well, if you notice, if I reverse it, it kind of helps a little bit if I use instead the second formula. So sometimes when we have a number less than 1, we use this formula up here instead. If you have a number bigger than 1, use this formula so everything stays positive. Here, your number less than 1 will make this a tiny fraction, so you'll keep it positive if you put it in this order instead. So I use the second one, 1 minus -1/3 to the nth power, divided by 1 minus -1/3. We cannot separate this because it's a negative taken to an nth power. So I can't change that to a positive, because if this is an even number, this would change into a positive, which would make the minus sign remain. So you have to be careful there. But here, this 1 minus -1/3 becomes 4/3. So now what did I do? I reciprocated that, right? I multiply it by 3/4, so I get 27/4, so that's why I have 27/4 here, and then I keep this part the same to get 1 minus -1/3 to the nth power. Now the same thing would have happened over here, except with it reversed, you would have had a -27/4, right, and then a -1/3 to the nth power minus 1. That was also your option, your second option. So if you had this one, that's fine too. They're both correct. And finally, our last problem, number 4. As first prize winner in a lottery, you are offered $1 million cash, or a prize consisting of 1 cent on July 1st, 2 cents on July 2nd, 4 cents on July 3rd, and so on, with the amount doubling each day until the end of July. Which prize is more valuable? In other words, which one puts more money in your pocket? Which one would you choose? So take a moment and try to calculate that. Obviously the $1 million, there's nothing you have to do, but now what's happening here? It went from 2 cents to 4 cents to, it went from 1 cent to 2 cents to 4 cents. So what's happening? It's a geometric series, right? This is the sequence, but if I put plus signs because I want to know how much it would be if I added it all up, right? And we have to go until we get to the end of July. Well, the end of July, just so you know, if you don't have a calendar handy, there's 31 days in July. So we're going to go for the 31st. So n equals 31. So go ahead and push pause and try it on your own, and you can see if you were right about which one is the better deal. Were you surprised? Which one would you choose? Would you choose the $1 million, or would you choose the increasing with your starting with a penny, then doubling it for 31 days? So your first term is just 1 cent, or 0.01 if you want to start it that way. Your n was 31, there's 31 days. Your common ratio, you're doubling it every time, right? So we have 1, or you could start with 0.01 here. So maybe that would be more interesting. 0.01 times 2 to the 31st power minus 1 divided by 2 minus 1. Well, 2 minus 1 is 1, so we have this answer. When I subtract 1, I would get this answer, but then if I multiply by 0.01, because remember this is in cents, so to make it in dollars, I just have to move the decimal point twice to the left. Well, let's see how much is that. Looks like $21,474,836. So $21,474,836.47. I'm thinking this is the better deal. That's it. That's geometric series. You did arithmetic, geometric, and I'll see you in class to continue with the assignment.